This is another type of factoring. This factoring has two terms. We're only going to handle the two terms that are the difference of squares. There is another technique for the difference of two cubes and the sum of two cubes, but there is not anything for the sum of two squares. So we have the difference of two squares. It's x squared, which is a square. 16 is a square, and we have a difference. This is automatic. It automatically will factor into two binomials. Factors of the first term, x squared, go first. Factors of the second term, 16, go last. And then connect the first pair with a plus and the second pair with a minus. You can double check by foiling. X times x is x squared. The inside product is 4x. The outside product is negative 4x. That means they cancel. And the last term is minus 16. So that is factored correctly. The next problem is 16x squared plus 49. I did say the sum of two squares is not non-factorable, but many people try to do it. They say 4x and 4x. They say 7 and 7. If they make them both plus, they get the last term, but they get an inside and outside product of 28x and 28x or 56x, which we can't have. If they make them both negative, likewise, they get a middle term. If they make one negative and one positive, now the inside product and the outside product will cancel, but the last terms is a negative 49. So the sum of two squares is non-factorable. And for our next problem, we have 9 minus 64b squared. Don't turn this around and put the b squared term first, because then you have a negative coefficient, and then it won't look like the difference of two squares. It is in the form of the difference of a square and a square. So factor in the order given. Factors of the first term go first. Factors of the second term, or square roots of the second term, would be 8b. They go last. Connect the first pair with a plus and the second pair with a minus, and that is the correct answer. As I said in previous factoring, we always should look for a common factor first before we use any of the other techniques. And in this problem, 3 is common, 3x is common to both terms. So we're left with x squared. 3 into 48, I think, is 16. And the x has already been taken out. So we have factored, but not factored completely. The binomial is factorable again as the difference of two squares. So x and x, 4 and 4, plus with a minus. That's the completely factored form. Let's see, we were asked to factor this. We have a 9 parentheses x minus y minus a squared times x minus y. I don't want to multiply out, that's going backwards, but I do see that we have two terms, and there's a common factor within both terms, which is the quantity x minus y. That is the common factor. What is left is 9 minus a squared. But we notice that this factor can refactor again as the difference of two squares. So we have x minus y, 3 and 3, a and a, plus and minus. This is the completely factored form of the original problem.